you're in trouble if you talk to yourself, but hopefully I think the real problem is when you start answering yourself, if I remember right. But today what I'd like to do is talk about a paper that I put together with several people that I'd like to mention. But I also want to stress right up front that really the genesis of this paper and much of the thinking behind it is the result of interactions with many, many people who are really the silent contributors to it. And I just can't acknowledge all those people at one time. The presentation there. There we go. Okay, it just showed up. So first off, let me acknowledge that the other people who are on this paper, Kevin O'Hara and Scott Stevens, are both at UC Berkeley, and then two folks with the Forest Service PSW, Pete Stein and Bill Zielinski, had major contributions to this work. And so I hope you view this really as a synthesis of several people's efforts to try to figure out possibly a way forward for forest management in the Sierra Nevadas. And so that's principally what I'm going to talk about, is an effort to try to integrate wildlife habitat and forest restoration resilience into efforts to achieve fuels reduction within the Sierras. To keep myself on track and so that I don't ramble all over the place, let me give you a little sense of where I'm going to go, a kind of roadmap. I first want to give some background as to what the genesis of this, the context was, both forest management issues, even some of the political context that's driving the effort behind this paper. And the motivation for a new forest strategy in the Sierra Nevadas. I don't think any of those points are particularly going to be news to anyone, but it's probably helpful to recap what they are so that some of the points I'll raise hopefully will be relevant to addressing those. And then particularly going into some of the problems that I think need to be overcome with any management strategy. I'm then going to talk more specifically about the paper and its concept of using topography as a means or a template for varying forest management, both within across a landscape as well as within a stand itself. I'll then discuss a paper in which we did an application of those guidelines, and finally talk about the response that we've gotten so far from both scientists and managers. So a little bit of background here quickly, probably very familiar to most of the folks looking at these slides, but hopefully it'll give us some common ground or context. To begin with, I think one of the first things to realize is how strong of a shaping forest fire has been in the Sierra Nevadas. And so Scott Stevens a few years ago did this really excellent paper trying to back into some estimates about how much of California used to burn historically, particularly in a pre-European context. So you see here a few numbers to consider, and first off is that at least in the modern era, since we've had kind of effective fire suppression, 1950 to about 1999, we've had wildfires burning on average about 250,000 acres a year in California. In 2008, for those of you who are around, we had a massive lightning storm in June that set off simultaneously, I believe, something on the order of over 2,000 fires and just overwhelmed the firefighting forces. And because of that, we ended up with a tremendous amount of burning that happened that year, 1.4 million acres. Now, to put that in context, before 1800, so before largely most of the influence of Europeans, the estimate was that in California you probably burned each year about 4.5 million acres, of which 1.2 million was forest. So ironically, that year of 2008, which many people considered somewhat of a catastrophe, many complaints about smoke, particularly in the Central Valley and I think up and down the Sierras, that was probably the closest analog we have to what might have happened historically in California. And then a final note is how are we doing in terms of trying to either put fire back in the landscape or deal with the fuels problem that we've gotten ourselves into with fire suppression. And some of the estimates on that are that basically, I think this is Forest Service numbers alone, so not other land management agencies, but that the target for the U.S. Forest Service is about 125,000 acres a year, but the average has been more, something on the order of 50 to 65,000 acres a year. So within this context, I think that another important thing to note is that if we're putting fuels treatments in and trying to reduce the fuels conditions in the forest, are they effective, and if so, in what context? And I'm not going to go into a lot of background on this, but I'd say that particularly there's several papers now that have come out that really show very compelling evidence that fuels treatments, when they're done properly, and that particularly means reducing not just the ladder fuels, but the surface fuels. So the surface fuels seem to be one of the strongest drivers, actually, of fire intensity. Is that when those fuels treatments are done correctly, they're actually highly effective. And there's several papers now that are out on that and kind of documenting what circumstances they work under and which ones they don't. So to my mind, that brings up the question then, why are fuels treatments stalled? So I'm going to move into this section in the talk about discussing some of the problems or limitations that may be constraining fuels treatments and in general forest management in the Sierra Nevadas. So a couple of points here in terms of the economic context. Almost 50% of the Forest Service budget is used for firefighting and training. Those numbers fluctuate a little bit depending on how you count the different beams, but generally it suggests that there's a high proportion of the Forest Service budget dealing more with what I would call the effects of this problem rather than the preventative actions of it. Dealing with the firefighting, the end product or the disease, rather than the preventive health type of approach. Large-scale fuels treatments, which are needed, usually most of the time do not pay for themselves. It depends on what type of treatment is being instituted, but generally economically, particularly with the current wood situation, the wood markets, it can be very difficult to do that. The third point is that there's a particularly kind of difficult line to walk in that when a forest is thinned or thinning merchantable trees, which might help with some of the costs of putting fuels treatments in, it's very difficult to make the argument that those trees actually can reduce wildfire intensity, because in most cases you're dealing with larger diameter trees that are really not contributing much to the fuel problem within the forest. So if we take out that component and we're looking at treating the forest without that merchantable component to it, probably most effective fuels treatments to reduce surface and ladder fuels cost roughly somewhere between often $800 or $2,500 an acre. So what I'd like to do now is slide a poll over and see and ask a question that hopefully will, I'd be very interested in people's response to this, but trying to look at what do you see as the biggest obstacles to increasing the number and size of fuels reductions treatments? On here. Let's see, I need to figure out how to remove this so I can see the slide. Well, I just need to move it off to the side so I can see the slide. The second problem I really want to discuss is the provision of wildlife habitat in these forests. One of the things that certainly limits how often fuels treatments are put in is, depending on the context of where the treatment is going in, there can be litigation. And often the litigation centers around whether there's sufficient provision for sensitive species habitat. And I've shortened that to TES. If I use that acronym later on in the talk or on one of the slides, that's what I'm referring to as threatened and endangered species. And principally in California, I'd say probably the two ones with the largest impact on forest actions are the Pacific fisher, which you can see in the bottom left on the slide, and on the right-hand side, the California spotted owl. And the core of the problem there is that both of those species and several species associated with old growth conditions have been shown to be associated with fairly high density forests in which often there's high canopy cover and a high loading of surface and ladder fuels. So it appears at first blush that you have a direct conflict with fuels reduction, because the TES, those particular threatened and endangered species, tend to be using those very forest conditions that will make fire managers nervous. The third point I want to talk about has to do with something that's affected kind of all of us, is climate change and ecosystem restoration, and what's kind of coming down the pike at us because of the changes in climate conditions. And there's a general pretty strong consensus that one of the impacts that will occur because of that is that you'll get an increased length in the fire season and probably a decrease in fuel moisture, making generally fuels and forest conditions even more flammable than they are at present. The reason that I think that becomes kind of important is it raises a fundamental challenge to forest management, which is that often what we've been trying to do in the last decade or two is use pre-European conditions as some kind of a measure in which we assess how well we're doing in terms of forest management. The thought is that those forests that used to have active fire in them can give us a sense of what the structure and composition in forests should be like, an objective that we'd like to get to make those forests more resilient and also better aligned with, for lack of a better word, kind of the evolutionary environment that would have shaped a lot of those species of concern. But of course, with climate change, we have to acknowledge right up front that maybe the past is not necessarily the best analog or example for us to use. So how do we use the past in that kind of context? And I think particularly the question becomes, how do you measure restoration, and what do you measure it against when the whole background condition is shifting as it is under climate change conditions? Another problem certainly with fuels treatments is the need to increase forest heterogeneity. And I don't intend to insult anyone who's worked in fuels treatments out there. I've grossly simplified the type of fuels treatments out here, more to make a point than to say that this is absolutely what's happening out there. But I think generally there's been two types of approach: a defense zone, which is an area that you absolutely want to hold the fire in and be able to get suppression forces in to be able to contain the fire. And then what's often referred to by the acronym SPLAT, or strategically placed area treatments, is treatments within the matrix of the forest designed to generally slow down the speed of the fire so that it becomes more manageable to either contain or for suppression to put out. But particularly if you look at the left-hand side, the picture there, the defense zone treatment, you'll see that one of the objectives in those zones is a pretty even spacing of the trees so that the tree crowns are separated. The thought is to reduce the potential for crown fire to travel from tree canopy to tree canopy. But of course, that does tend to produce a forest structure which is almost grid-like or very systematic. And there's very compelling evidence from almost all the historical photos and the reconstruction that that type of condition does not have an historical analog, i.e. that we really don't ever find that kind of regular spacing in the forest historically. So ecologically, that tends to set off red lights and bells of, are we producing something that the species in the forest and the processes in the forest may not be adapted to because they haven't, so to speak, seen it before. So one of the challenges with trying to increase that forest heterogeneity is that if you're going to produce different conditions out there, how do you identify where you're going to have different fuels loads and different forest structure? How do you come up with a conceptual model or an idea about how you would vary forest structure in hopes to make it more resilient to what's coming down the line with climate change, but also possibly to be able to provide some habitat for some of these sensitive species that clearly are associated with forests that often have higher fuel loading conditions. Let me next ask, I want to try this next poll, if we can take a look at that. and I'd be interested in getting people's response to this. What do you think is the most important factor when designing fuels treatments? And I've got a list of various ideas down there, but I'll be interested to see how people respond to that, because I think that fuels treatments in and of themselves can end up with many different potential ecosystem attributes that you're trying to meet, and sometimes those are not simply the reduction of fuels alone. What I wanted to do is show with this slide is just kind of give a graphic presentation, going back actually to that slide several slides ago that was based on Scott Stevens' work about reconstructing historical fire patterns. And so if we look at three different conditions that we've gotten ourselves into, I think it's kind of illuminating to see what we're arguing about and where we're at in terms of this process. So the left-hand bar is the relative size of the acreage that's treated each year. The next bar is that if you look at what should be treated each year, trying to reconstruct it from historical conditions, saying, well, fuels would have been reduced on so many acres on average each year, you're looking at something that's substantially higher, about 1.8 million acres of forest each year. And then if you do some back calculations, and I'll be the first to admit there's some hand waving that goes on in this, you try to make a back estimate of not only what gets left untreated each year, but what is the total backlog when you add up all these years that you've missed treatments. How many acres of forest are there out there that actually require or should require some kind of fuels treatment in there? You can see that you get a number that's about 10, 11 million acres per year. The interesting thing to my mind is that we seem to have a lot of controversy and conflict over what little acreage we are treating each year relative to what we need to be thinking about and where we need to be going. And if this seems really silly, which sometimes I tend to think it, I was interested when I was looking at this that this was a couple months ago when I first developed this graph, that the relative size of these bars is almost exactly identical to the budget reductions that were being argued about in Congress in the left-hand bar, the annual deficit in the middle bar, and then the size of the total debt in the United States in the right-hand side of the bar. You have to multiply all those numbers by 1 million to get them up into the trillions, but the relative, you can see that again, there can be a lot of storm and strunk and controversy over something that's actually a very small amount of what the problem is that you're trying to deal with. So I'm going to shift gears now from kind of the context of the problem to giving you some idea of how this paper came about before I launch into some of the ideas and suggestions that it brings up. So certainly one of the impetuses for the thinking about a new management strategy in this years would be, how do you create those variable forest conditions that could do more than just meet fuels reduction targets? But you could also think about managing forests for forest restoration and the provision of wildlife habitat. And how this effort came about is there's a project down in the Sierra National Forest, the Kings River Project, which had been attempting to go forward for over 15 years and had repeatedly failed to pass muster with the public and with stakeholders, even after mediation efforts, and was a very controversial project, in part because it's located in an area in which there's the Pacific Fisher and the southern population of the Pacific Fisher, which is where the Kings River Project is located, is a very small, potentially very tenuous population. So it certainly takes some scrutiny to figure out how we'd want to manage forests in that area, reducing fuels, but also without impacting the fisher itself, as well as the spotted owl, which is present there. So in 2007, the Forest Service Region 5 asked PSW Research if they could summarize science in several different areas and be able to develop a summary that might be able to synthesize that information and be scientifically defensible. and also asking if it brought to mind any suggestions about how you would manage forests in an era in which you have climate change. Getting back to that point I mentioned earlier, that the difficulty with climate change is it brings into question the use of historical conditions and what they can actually tell us about managing forests. And I'll get back to that point later. So to my mind, when Pete Stein gave me a call and said, "This is your project, Malcolm," and I was like, "Oh God." The first question I had is that if we brought together a group of different people, particularly with backgrounds in fire science and forest ecology and wildlife biology, if you ask those people how they would manage the forests for the particular process or wildlife or whatever that they focus on the system, would you end up with contrasting management schemes, or would they somehow end up being complementary? And if they were complementary, could you actually take those ideas and translate them into silvicultural practices? And the interesting thing, that it became clear very quickly in these discussions that the really important thing that kept on coming out was efforts in management to try to create variable forest structure and fuel conditions. And if you got that variability and you did it correctly, you might simultaneously be able to meet the goals of ecological restoration, forest resiliency, fuels reduction, and wildlife habitat. The real crux of it was trying to figure out a method for managers so that you could implement that variability and communicate it in a way so that members of the public and stakeholders could appreciate and get some kind of input or understanding as to what the thinking was behind the patterns that were being created out in the forest. The paper originally came out in 2009. I just list here some of the different categories that were addressed within the context of the paper, and then we actually went through all the editions of it and ended up putting out a second edition with an addendum at the front, 6 or 7 pages, I think, that tried to address some of the issues that had come up several times, that managers had pointed out, either things that were unclear, or places where we definitely overstated what could be supported by the literature. So let me talk a little bit about the central concept that's being used in this strategy. And the basic concept really relies on going back to the point that fire was probably one of the strongest influences in these landscapes, at least within the forest types that depended on fire, had active fire regimes, particularly the pine and the mixed conifer zones. And one of the things we do know about fire is that its intensity and the way it ends up behaving on the landscape is influenced by several factors, many of which we can't control or don't know that much about, such as weather conditions at the time of the burn. But certainly one of the things that clearly influences fire as well is the topography itself. Fires tend to burn hotter and move faster on steeper slopes and southwest aspects. And when they get in more mesic conditions or flatter conditions, fire frequency isn't quite as often, and the intensity is usually not as high. So the thought was to look at this as possibly a means of creating some kind of guidelines by which you could vary forest structure and fuels conditions in managed forests. And if you go into places, and there's only a few of them we have in the Sierras that still have active fire regimes, I think you can see some of these patterns out there. So the left-hand picture there is a shot from Aspen Valley, which actually has had 4 low-intensity burns just within the last, I think, 45 or 50 years. And to my mind, one of the things that photo shows is that you have a fairly wide open forest in the foreground dominated by pines. But if you'll notice in the back and the middle, there's a drainage in there, and you have a much higher density of stems, and you're also starting to get some of the fir and more fire-sensitive species, and providing areas in which you've got some structural variability, but it's in response to little changes in topography. And in the right-hand side shows what you often see when you get towards a ridgetop with thinner soils, but also where fire tends to be reducing the stand density and opening the stands up, a really contrasting condition with river bottoms and drainages. So we thought about what would this look like if we schematically produced it, and this is an effort to try to show what that might look like. And you'll see that it really hits on that concept of trying to have higher density and fire sensitive, shade tolerant species in the places that are more mesic, the cold air drainage down the middle of that picture, and then in the foreground the little concave area. But as you move to conditions that are going to be drier, in which fire would have burned more frequently or with higher intensity, you're shifting to a much lower density forest and one that's much more favored by pine, which is what's kind of shown in the back on the left as you're going upslope. The same kind of concept we were thinking should equally apply at a much larger scale at the landscape level, in which you also have strong influences on fire and how it affects forest structure and fuels. And the drivers there are often the slope position where the forest is actually at, whether it's in the drainage bottom, mid-slope, or upper slope or ridgetop, the steepness of that slope, and also what its aspect is, particularly whether it's facing more towards the southwest or the more mesic sheltered conditions in the northeast. So similarly, what we tried to do here was produce a general schematic of how that forest might look, where treatments would produce different forest conditions depending on those factors of slope position and aspect. And so that you end up in a condition in which you might be able to provide some of that higher canopy cover and higher density conditions associated with sensitive wildlife down in the bottom drainage here, as you see along the river, where you can support pretty high canopy cover, more fire sensitive species. But as you move up, and particularly on the left side there, as you're moving towards a more southwest aspect, you see the forest thins out and switches to pine fairly quickly, as on the right side, going up towards a more northeast aspect, it can support a little bit higher density, but still tends to thin down or reduce down to a lower density as you get higher in the slope position. I want to return to a point mentioned earlier about how do you measure restoration, or what you might measure your forest management practices against when you've got changing climatic conditions and you don't want to simply wind the clock back to what the forest looked like in 1850. And there's a lot of papers and discussion that have gone on about this, but I think the general consensus that at least the scientific communities move more towards is that history still has a tremendous amount of value for telling us how forests can respond to these conditions and how they can be resilient. But maybe the lesson from history is not so much to exactly mimic the exact processes that went on in those forests, and try to make sure that we restore those processes in the current conditions. Because of course forests, if we end up with a much drier situation, may not support the same numbers of large trees, or may support a different forest composition. But thinking about what drove that forest to have that kind of condition of trees, and how we might try to replicate those processes, may be a more fruitful way to think about using the past than trying to strictly develop guidelines that say we need, let's say, 8 30-inch trees or more per acre. This was a topic that I think the group of co-authors and I felt very tentative about going into, because it deals much more with issues that in part are determined by economics, but also I don't think you can really talk about forest management in the Sierras without dealing with this 800-pound gorilla, which is that most of the time our surface fuels and small trees, we're not going to be thinning the trees which might be able to help pay for some of these things to occur. And so it's a bit of a gross simplification here, but we thought, well, what would be the criteria that might justify cutting trees in that what's generally the merchantable size or commercial size of tree, which in the Sierras is generally about 20 to 30 inches. And the thinking is that you're not really going to affect fire behavior. It's not really going to be effective fuels treatments. But there are reasons to think about thinning those trees much more for ecological restoration purposes. And particularly when we look at how resilient those forests were historically, it gives us some idea about the need for large, widely spaced trees, particularly pine, fire-resistant trees, in those parts of the landscape that historically would have burned more frequently. And so here we were looking at talking about some of the criteria that might go into considering thinning those larger trees. Certainly a species preference of trying to reduce the fir and the cedar in the forest, and by what you're leaving behind, increase the percentage of pine, and generally limiting those thinning of larger trees to the places where fire would have kept a low density of trees, so the mid and upper slope topographic positions. And then also considering where you do have large trees which still can be ladder fuel trees, such as you can see somewhat in the photo on the right-hand side, where there's a 30-inch tree, but it has live foliage all the way down to within about 6 feet of the ground. And finally, there's definitely a pretty strong amount of literature suggesting that there's a high correlation between increases in bark beetle mortality and drought stress. I'm certainly not advocating eliminating all bark beetles, and the mortality they create actually on a patchy or variable scale is really beneficial to the forest. But we can get to a tipping point, as we've seen in Southern California, the San Bernardinos, where the beetle mortality can dramatically increase to a really large scale. And it's clear that reducing the drought stress in these forests in some of these places would make those forests more resistant to bark beetle mortality. I also want to look at the economic issue at a landscape level, because I think one of the things that bothers me a lot in the Sierras is that we tend to stay out of managing the areas that to me are some of the highest value. It's hard to say that one place in the landscape has more value than another, but certainly if we look at riparian forests where we know there's really high species diversity, and we look at sensitive species habitat, that's that we know that spotted owls or fish are using, those zones, those areas are generally going to require lighter treatment, and because of that, there's going to be very little potential for the material that's removed out of those sites to pay for the treatments. I think that, combined with the fact that going into those areas can increase the chance of litigation, means that a lot of the Sierras currently, the very places that we most prize, those places that support some of these sensitive species in riparian forests, have some of the worst fuel loads, and they're most susceptible to both high severity wildfire as well as kind of continued degradation from really high stem densities and drought stress. So what I'm hoping we think about on a landscape level is maybe coupling areas so that when you have commercial dollars that you might be able to generate from treating an upper slope condition where you'd want to thin it a little bit heavier, that you might be able to use those revenues to support what's going to be a lost economic or lost cost area, which is treating those areas down along the streams or in the sensitive species habitat, so that we can make sure that those get treated and they don't just get left to be avoided because of litigation and cost problems. There's several other concepts that are put forth in the GTR, but a couple of ones that I think are worthy of mention that kind of tear off of some of the concepts of topography and variability. And certainly one of the things that I think set off a lot of, as I mentioned earlier, a lot of kind of bells and whistles for the scientists involved is this tendency in some forest treatments to leave trees evenly spaced, when pretty much all of the reconstructions and the information we have is that these forests in the Sierras historically were very clustered, with gaps in between them, and between those kind of often a matrix of a low density of trees, a fairly open forest but with scattered trees. And in the right-hand side, you can see a shot of a place called Beaver Creek Pinery, which has what we might consider close to an active fire regime in it. And it definitely has that structure much more, where the trees are clustered in groups with intervening gaps, because our fire models currently are not very good at being able to model that effect. So it's hard for us to be certain that that will be just as effective in reducing crown fire as evenly spaced trees. But the places we do go and look where we have active fire, such as the Martier in Baja, Mexico, or Aspen Valley, or the Illilouette in Yosemite, you see this kind of structure, and obviously the forest has been pretty resilient to crown fire with this kind of gap, groupy type of structure. Another point I constantly want to stress is that the topography is by no means a mandate. It's kind of a concept of increasing variability, but oftentimes you have to work with the conditions you've got in front of you in the forest, and simply tearing off of those conditions where you can create a gap, where you can leave trees in a group, is going to be as effective, if not more effective, than trying to strictly adhere all the time to topographic variability. But the concepts that I think topography talks about and drives are still valid. Certainly another thing that's pretty clear in the forest is the need to retain more defect trees because of their strong association with wildlife. And I think there's been a propensity in the past to view trees that might have some kind of defect in them as genetically not as fit for the stand, and so there's been a tendency to clean them out. I think we've gone long past that now and currently in the forest, but it's a point that I really think can't be mentioned too much, because certainly one of the things that's probably even rarer than large old growth trees in these forests are large old snags or large trees that have cavities and platforms and structures in them that would be useful to wildlife. And finally, going back to this concept I mentioned earlier about the economic incentive, that riparian forests should be a priority for fuels reduction, because currently we do know that those areas actually have the highest fuel loads of almost any place within the landscape. So I'm going to quickly go through just a few last points here, and the first was to try to take this concept and at least conceptually apply it to a landscape. And so what you see in front of you is an area, again going back to that area of the Kings River that I mentioned earlier that was controversial, in which we binned the landscape using some GIS algorithms into these different slope positions and aspects, producing 9 different categories, what we called LMUs, or landscape management units. And then once we divided up the landscape and we weighted those relative to how much acreage they were, we looked at where 2 sensitive species were within the context of those landscape categories. Now the first slide shows you that spotted owl nests fit the concept that we've mentioned, that they generally have higher than expected numbers, significantly higher than expected numbers in those canyons, those drainage bottoms that also have higher canopy cover and stem density, and lower than expected numbers on the ridge tops where you have a pretty wide open forest. Similar story when we look at Pacific Fissure using telemetry locations, that you have higher than expected use in canyons, again with a high canopy cover and higher stem densities, and lower than expected uses on ridges. Now there's a lot of factors that could be driving these things, but I'd say the analysis is suggestive that at least within this context, the present location of those species do seem to be associated with the places that, because of their mesic conditions, are supporting higher canopy covers and densities within the landscape, so that there's a sense that you might be able to provide for these species and in other places still reduce the fuel loads to be able to accommodate both fuels treatments and wildlife habitat. So quickly, I'm going to sum up here with both a response in the scientific community and the management community to this paper, and then I'd like to open it up for any questions or comments people have. But the paper did go through a lot of reviews, and including 7 blind reviews in the scientific community. And you have to love the peer review process. It's always something you need to pick yourself up off the floor from after you get the reviews back in. But one of the ones that I've quoted here actually struck me as ironically in a certain way, a backhanded compliment, and let me explain here. But the quote itself was saying, considering the creativity of the authors involved in this report, I would have expected some new ground to be broken. And what it made me realize is that in terms of providing something to forest management, I don't think you necessarily want to be on the cutting edge of science. It's a very controversial and kind of a full contact sport. But if you can step back 2 or 3 years from that edge and look at what the body of the scientific information suggests and build it, bring it together in a narrative, that may be potentially more useful to me for what the reviewer is talking about. For the scientific community, it may be boring, but the reason it's boring is because, to my mind, it's not controversial, which I would consider an asset for management. The forest management response has been kind of interesting, which is, you know, duh, we know this stuff, and I certainly would not disagree. Almost every time I'm out in the field talking with people, they are well aware of these concepts and then putting them on the ground. And there's rarely such a thing as a uniform fuels treatment or you know, a regularly spaced leaf tree, except I would say in those defense zones. But in many cases, I think there's been a kind of a frustration that civiculturalists on the ground may be doing the right thing, but have had a very hard time expressing it to stakeholders in the public. And to me, it made me realize something that I'm hoping that this paper, this GTR, can help with, which is that I think there needs to be a way in which there's a conceptual framework built that expresses what the ideas are, what the concepts are, that's guiding management overall. And from that, I think it's easier to communicate with the public and with stakeholders about what the intentions are and why you might be creating variability out there. And furthermore, I think it allows for some transparency and verification by stakeholders, because they can go out in the forest and take a look and see, are you indeed thinning the forest lightly in riparian areas or sensitive species areas, and maybe thinning it more for restoration purposes on higher slope positions or southwest aspects. To just recap what started this process and where it went, the Dinky project, which was the genesis of it and the controversy, the GTR, I think, helped a little bit. There was a tremendous mediation effort that went into resolving it, but that project has moved forward, and not only moved forward, but successfully competed for and got a large-scale grant from the Washington Office of the Forest Service to do restoration on over 100,000 acres in the area. The Forest Service is also considering using the GTR as some contribution to its next round of forest plans, and has projects going on in most of the national forests in the Sierra Nevadas, using it to one degree or another. But I would caution that the support, which has been really surprising and great to see, I do think is always going to be contingent on political forces that may or may not persist, and will be strongly influenced by the outcome of the first legal challenge when one of these projects is challenged in court, and what the judge decides in such a case. So just in conclusion, a couple of points I'd like to make is that I think that at the core of this concept is the idea that in fire-prone forests, the risks of carefully considered management are lower than the risks of inaction. And I think that has to be a starting point to say that there is a justification for going in and doing something rather than leaving the forests alone. But the best means of providing possibly habitat for sensitive species and fuels treated forests may be to try to produce resilient and variable forest conditions that the species evolved with, and that we can look for guidance for that from topography and how fire interacted with topography. And my sense is that can only happen if we can reach some common ground about allowing fuels treatments to be widely implemented. And hopefully the GTR can help with providing a conceptual framework or kind of a blueprint for how forest conditions could vary in a landscape, and at least a starting point for that conversation. Thank you. Thank you very much.
All right. Thanks, Malcolm. So we've got some good questions going on over in the chat box. I want to encourage everyone to keep typing them in over there, and we'll move them over here for Malcolm. Also, while we're doing this question and answer, we'll put some of these polls onto the screen too that we had to speed through a little bit just so folks can get everyone's feedback on those also. So the question is from Christine West. She wanted to know what program you use for these models, and I believe she was referring to the topography and species composition pictures.
Okay. The paper in particular that was the first kind of testing of the models with those two slides that refer to the spotted owls and the Pacific fisher was developed in ArcGIS, and we've since built macros that anyone can download from a site to apply to a landscape and bin the landscape into those different topographic categories. Not so much to say that this should absolutely be done in that particular area, but that it may be useful as a planning or a communication tool to suggest different treatments that might occur in the forest. And there are two versions of that macro that we've built. One that follows the terms and the search radiuses and so forth for their particular conditions.
Okay, and then the next question is from.
It's a good question.
Are invasive species affecting the fire?
And I'm sure that there's probably some folks out there with better awareness of this than I, but my general sense in the few studies I've been in is that we don't have a very high level of invasive species currently in the Sierras. Conifer forests, not just in the Sierras, but even the Pacific Northwest I've worked in and other places, are somewhat resistant to invasion by invasives. So, you know, we do get Scotch broom poking into the forest a little bit. There's certainly some concern about star thistle and puncture vine moving up, but so far I have not seen dramatic increases in invasives within the interior of forests that would affect either the fire behavior too much or possibly reduce the habitat value for wildlife.
Thanks. Next question is from Bernard Volkel. It's, have you researched how the low value ladder fuel trees and slash might affect the treatment costs when you use biomass and cogeneration power?
Hopefully probably just cast more obfuscation on the issue, but my general sense in talking with people who know a lot more about the economics of this issue and looking at it, people like Bruce Goines and Mark Meckenham and others, is that there's to get biomass out of the forest. The market currently is not sufficient. The dry tonnage acreage needs to increase from what it is right now without forests or without some kind of government incentives or programs. At least right now, the economics are difficult to make work. There are always exceptions to that, and there are places where that infrastructure is much better set up. I'm thinking of the Lassen National Forest and in the Southwest, some areas in Arizona. But currently, at least the places I've seen, I would love to see biomass take off and work, but at least to my knowledge, it cannot pay its way out of the forest at present. I guess I'm going to have to confess right up front that I'm a little biased on this because there are probably the two papers
that out of whack
that address it, and a half, both of them in Sierra Forest Ecology and Management. But we looked at 35 streams in the Sierras and first tried to assess what the historic fire regime was like compared to what it is currently, both in the riparian area and for comparison in the adjacent upland area. And then used techniques in forest ecology to try to reconstruct what the forest looked like historically. And particularly when you reconstruct what the forest looked like historically versus what it looks like now, the fuel loads in many of those streams are even much higher than they are in the adjacent upland forest. And when you model those areas in using fire models, the amount of mortality and the severity is actually much higher in those riparian areas than they are in the adjacent uplands. So I hate to kind of reference or cite myself, but at least those are two papers that try to directly address that issue. And there's an older paper by Scott Stevens that came to somewhat similar results, although I think it's on a more limited set of streams up in the Tahoe Basin.
Hey, no problem with citing yourself. Don't worry about that. Question number five is from Kathleen Stoof. It sounds very interesting to create a forest structure using topography. I wonder about the feedback.
So,
fire risk.
I heard part of it, but I can read the question, fortunately, in front of me. So if you can hear me, I can go ahead and try to answer.
Designed to be more sparse. The differences in microclimate may exacerbate the.
You do have to look at the fact that if topography is going to drive some of these conditions, and you've got moisture and cooler areas in, let's say, riparian bottoms or drainage bottoms in the landscape, what are you doing in terms of treatment? Are you going to alter the microclimate conditions? And one of the things that the GTR is specific about, and that we've been trying to push hard is that if you are going to do fuels treatments in those areas, they should by no means be attempting to alter the microclimate, so that those indeed are the areas in which you're constraining what you might be thinning to understory trees, and you're not changing the overstory canopy cover at all. And so hopefully, we would need a study to look at this, but hopefully the effects on microclimate would not be altered very much, because you're constraining yourself to really removing the smaller size trees. But that does tend to feed into that point I was making, is that those areas which I would love to see us be able to put some prescribed fire into, or at least reduce some of the dangerous fuel load, generally they're not going to pay for themselves to have happen. And so that I hope we can find a way about getting fairly mild treatments into those, whether that be a light prescription, probably supported with either a service contract or money from some other place in the landscape. Yeah, it's a good question. I'd say that the first off rule of thumb for me would be that I think you want to make sure that you provide places in stands and within sensitive species, and those clearly appear to be for spotted owls and for fisher, high canopy cover levels, and some kind of often larger structures, snags, trees,
the sixth question, I think you touched on a little bit during your presentation, but you can get it again. It's Carl DuPont.
And to me,
summary, can you list some rules of thumb
for integrating wildlife habitat and some of that without having it burn up is to make sure that the forest landscape overall has other places in which you have reduced the fuel loads, but done it in a way in which you're restoring the forest towards a more resilient condition. And if those heavier fuels treatments are done in places where you'd want low density open forest conditions, upper slope positions, I think you can have a fire move into a landscape like that and still retain. Okay. Oh, okay. Well, you know, you found me out. I actually believe that good forest management is an art based on science. It has to have the foundation of science, but good civiculture, good forest management has to have flexibility, and that flexibility is going to mean that no two people are going to mark or thin or manage a forest in identical ways, and each one of those areas or stands out there might look a little bit different depending on who does it, and that's part of the art of it. But to my mind,
number 7 is also from Carl.
if the way the art
comment, I don't know if you'd like to comment.
Is implemented is based on science,
the
end product and the overall result is still going to be beneficial to the landscape, to the wildlife, and to the forest. And there should be some art. There should be some art in forestry. So you cut out a little bit, but at least what I'm seeing is there enough landscape variability created by people in subdivisions? I'm guessing it's to perform thinning, or would that impact thinning? The problem I think we have with where people in subdivisions are located is that they might not be optimally distributed if,
Combining those two always seems to be the challenge.
Any ecologists were deciding where people are, which locations and which places you could not build or put homes into. So, for instance, in the Tahoe Basin, you have a really high concentration of people in subdivisions, and there's been several studies that have looked at that area, pointing out that the connectivity for that landscape for wildlife is by no means optimum. And where homes are built, frankly, what often frustrates forest management is trying to figure out, first and foremost, how to protect those homes, which I agree needs to be the highest priority, but do it within a context in which we're still trying to meet some of these other objectives. And the people and subdivisions often can make that work more difficult, particularly if you've got areas in which people do not want to breathe smoke and are really adverse to any type of treatment that might reduce the dense forest conditions that they become accustomed to. Yeah, oh, that's a great question. I have some reservations about the framework, and I think a number of people do, because of a high focus it's put on canopy cover. Not that that is by any means a bad thing, but that it has sometimes forced a certain treatment that's really tended to clear out the understory in an effort to retain as much canopy cover as possible. And I
Thanks for
think
there.
what you may be referring to, and I certainly
Next
share this,
question
is
from
when you
Ane
look at
Otto.
some of these
Under the
CASBO
current
guidelines,
framework
California
guidance
Spotted
that
Owl
stresses
guidelines,
thinning from below,
and
how
you
can we
walk
create
into
this
those
variability and
stands,
heterogeneity in
and I've heard them
stands
referred by other
that have
people
previously
to
been
clear cuts from
thinned
below.
under
And it is true,
CASPO
you walk in
guidelines
and there
and
is
have little to
nothing
no understory
for the
currently.
first 40, 50, 60 feet until you hit the bottom of the live green crown branches. And I don't think many people would make an argument that that's optimal habitat for wildlife or achieving forest restoration purposes. So certainly one of the things I'm interested in seeing is that we try to look at more flexibility in these prescriptions and in these guidelines so that we can leave variable conditions and that we're not always hamstrung and always trying to hit canopy cover target. Yes, I have, and I think it's interesting. I've seen something similar, which I think was Wilderness Society. I know I got it originally from Greg Aplett, in which there's discussion, which I think is an excellent discussion that needs to get out there about thinking about the landscape in which you might have different zones, and you would allow different levels of fire, different levels of natural processes to occur depending on what that designation or that development zone is like.
A little bit again there.
And
Sorry,
I think
folks,
in
for the mic
California,
trouble.
particularly in Sierra
I think
Nevada, we
we'll
have to owe up to
plug on
that's
now here. We've
already
got
the
another
stage
question
we've
from
got.
Carl.
There's so much
Natural
development in
Lands
certain
Trust
areas
developed
in
a
the
program called
Sierras,
Smart Growth,
but there certainly are
which
zones in
delineates
which
the
the first
landscape
priority is
features
going
and
to
then
be
places
protecting
land development
structures,
in areas that have a minimal
and
impact
all
on the
other
landscape.
priorities are going to be
Have you
way
heard of
down
this
the
planning
list.
process?
But if we thought consciously and planned ahead for developing zones and areas in which you had different levels of both human development as well as different levels in which you allowed natural processes to occur, we might get more wildland fire use, which I know almost every forest and fire ecologist I can think of is a strong advocate of. Frankly, I think question.
Ask the question again.
That's a good question. Certainly, I think that a couple of the things to point towards is if you have very high densities in areas that we know are not as productive and that burn more frequently, it's an immediate kind of red flag that potentially you've got more drought stress conditions. So as you probably know, foresters often use stand density index or SDI. It's actually in terms of trying to predict beetle mortality, which is a direct result of drought stress. So far, it's been shown to actually be a reasonably good indicator. So I don't have any problems with using SDI in some of these areas to help identify places that are where drought stress is going to be more of a factor. But the other thing I would hope to see brought into the equation is how mesic or xeric is that location? How much biomass can it support? And certainly we have general rules of thumb.
It's also typed there, but I asked
areas
what specific stand characteristics can managers look for when determining whether drought stress is a factor that may justify large diameter tree removal.
More basal area is definitely going to result in a quicker removal to a drought stress condition in which beetles may become less of an a low-level endemic mortality force and more of a difficult disturbance pattern, larger scale. So I would say both the current silvicultural tool of using SDI, but making it sensitive to the particular productivity and mesoxeric level of the stand that you're using to evaluate it.